Hello everyone, welcome to this lecture series on ICMCFD meshing. This particular lecture is part of the introductory course on CFD modeling using ANSYS Fluent and ANSYS ICMCFD. This lecture will focus on prism meshing. Prism layers or prism meshing is a type of mesh within ICMCFD, and we will discuss all the details related to prism meshing in this particular lecture. First of all, the question comes to our mind is, what is prism or what is prism meshing and why do we need it? Prism meshing or prism layers are created when we extrude surface mesh elements in the normal direction. If we extrude tri elements, we get prism. If we extrude quad elements, we get hexa. But this general extruded layers of mesh is called as prism layers. Usually we have 3 to 5 prism elements that are extruded from a surface. Their height increases gradually so that it matches the size of the tetra or hexa elements within the core of the geometry. This is where we have the prism layers. As you can see, these are the prism layers in the zoom view. Now, why do we need to have prism layers? Accuracy of the numerical simulations within CFD depends on capturing the boundary layer phenomenon. The heat transfer coefficient, the turbulence, the pressure drop, all this physics are strongly related to how closely or how accurately we capture the phenomenon that is happening near walls or the flow that is happening near walls. In order to capture this, we need to have accurate mesh near the wall or a finer or unidirectional mesh near the walls. Hence, the mesh should be orthogonal to the surface boundaries. Mesh should also be perpendicular to flow direction to reduce numerical diffusion. Extruding prism layers in direction normal to the surface satisfies all these requirements, and hence we generally recommend prism layers in order to capture phenomenon of flow that is happening near the boundaries. Now, what is the procedure for creating prism layers? First step is to give the global prism parameters. For this, we go to global mesh setup, then to prism meshing parameters, and we specify the global prism settings. In the next step, we select the surfaces from which we have to grow the prism layers. For this, we go to mesh, then surface mesh setup, and then we click on the surfaces or boundaries from which we have to grow the prisms. In the next step, we set the local prism parameters on individual surfaces. Local prism parameters will override the global prism parameters. If we do not need to specify any local prism parameters, we specify 0 or leave it blank. In order to specify the local prism parameters, we go to mesh, surface mesh setup, we select the surface, and then we specify parameters like height ratio and number of layers. In the next step, we run the mesher. From existing mesh, prism layers can be created from existing volume mesh or from the surface mesh. If required, this option can run automatically after volume mesh generation. For this, we go to mesh, compute mesh, prism mesh, and then we select existing mesh and click on compute. So now we will discuss global prism parameters and how to set them up. Global prism parameters can be accessed by going to mesh, there is global mesh setup, then prism meshing parameters, and then we go to global prism parameters, and this is the panel in which we give the global prism parameters. Before we proceed further, let us discuss what are parameters which define prism layers. First is growth layer, then initial height. We have to also give number of layers as well as total height. All these parameters can be specified in the global prism parameter tab, which is here. Now let us see the growth law in detail. Prism elements near to the surface should be of small height so as to satisfy Y+ criteria imposed by turbulence model. But all elements cannot be of same height, as it will increase the cell count of mesh. Last prism element height should be approximately same as the volume element size, so that it merges or mixes well with the volume mesh. Now, in order to satisfy this criteria, prism height should gradually increase. This change in prism height is governed by something called as growth law, which grows the prism layer height, and there is a law established or a specific growth ratio associated with the growth law. Growth laws that are available in ICM are linear exponential and WB exponential. There is these different types of growth laws are available. Formulation is as given here. Mostly linear, that is, each linear growth law has this type of formulation, exponential has this type of formulation, as well as the WB exponential has a different formulation given here. Now, mostly linear growth law will be used. It is the simplest of the three to understand. Within this formulation, h is the initial height, r is the height ratio, and n is the number of layer or the layer number. Now, it is clear from this formula itself that what we need to give as input is initial height, height ratio, and number of layers. We will discuss all these parameters in detail in the coming slides. We will see an example here, growth of which shows the growth of prism layer with same parameters but with different growth laws. Here we see the linear type of growth law, which is growing the prism layer as shown here, exponential law, which is growing it in this fashion, and the WB exponential law, which is growing it in this fashion. You can see that the number of layers as well as the initial height is same, but the growth or the change of the prism layers as it merges with the volume mesh is different for each growth law. The next parameter is initial height. It is the height of the first element from the surface. This is generally calculated based on the simulation requirement. This can also be set to 0. In that case, ICM calculates it automatically based on surface mesh size. Initial height is shown in figure on the next slide. This figure shows growth of prism layers and will be used to explain different parameters associated with it. It is clear from the figure that initial height is the height of the first element extruded from the surface, that is this. As you can see, this is the initial height as shown on the screen. Now the next parameter that we will discuss is height ratio. It is the ratio of height between two consecutive prism elements. If ratio is 1, height of prism will not change. It is recommended to use a height ratio in between the range of 1.2 and 1.5. So the height ratio is the ratio between consecutive elements of the prism layer. Next parameter is number of prism layers. This specifies the number of prism layers to be created. Increasing number of prism layers will increase the cell count. It depends on which type of problem or what physics is involved, but generally we keep number of prism layers between 3 and 7, that is minimum 3 and maximum 7. So this is the number of prism layers. Currently there are 7 prism layers, so the number of prism layers is shown here. Next is total height. It is the height of prism layer. It can be calculated from initial height, growth ratio and number of prism layers. Sometimes total height can be specified so that initial height can be back calculated. In figure, overall height of prism layer is total height. This is the total height. As already discussed, to specify parameters for prism layer, one has to specify initial height, growth ratio, total height and number of prism layers. But these parameters are dependent on each other, so it is sufficient to specify any of the 3 above mentioned parameters and the remaining can be calculated. We have to note that globally defined prism parameters will be overwritten by local prism parameters.